Hello, my name is Pontus Rydin. I'm a lead technical evangelist for Wavefront. Today we're going to look at an application that's made up of several microservices and see how we can manage and monitor that using Wavefront. As you may know, microservices are a great way of developing an application because it allows you to have well-defined components that you can hand out to different teams all over the world. It also provides you with ways to test these in isolation, but all these microservices actually adds to complexity of the application. You may have so many services in your application that there's not one single person who really understands the entire application. Here's where Wavefront comes in with the observability functionality, where you can look at an application from a performance point of view, but also understand its structure and understand what the bottlenecks are. So let's dive right into this demo. It all begins here in Slack. In this case, I am some kind of DevOps person, and I am responsible for this particular application. And what I see here is that I have an SLO that's breached. It's the Web Store Order Completion SLO. And what that SLO states is that it cannot take more than 800 milliseconds to process an order in my web store. If it takes more than that, I'm at risk of losing customers because they get mad and they just simply leave my web store. So what I'm going to do now is I'm going to click here to get more information about this alert. Clicking on that link takes me to my business dashboard. Here, I can see how the application is performing from a business point of view. For example, I can see that yes, indeed, my duration for this checkout operation went up from below 0.1 seconds to about 1 second. So now I'm in breach of my SLA. Does that really impact the business though? Well, this particular application happens to be logging its revenue. So every time we sell something on our web store, we log that. And we can see that the revenue, in fact, did drop off quite steeply once we see this increase in time it takes to do a checkout. So we do have a problem here. We have a pretty serious problem because we're losing money. So what I would do now is I need to involve my developer. The way I do that is I just click here and I get a link. Now, in this case, I want to get a non-live link. Why? Because the non-live link will take the developer directly to this particular screen in context in the same time range. So I'm just simply going to copy that link and I'm going to Slack this to my developer. There we go. And now I can click there again. And yes, the developer will be taken to exactly the same place. Now the developer will look at this and say, yeah, it looks indeed like I have an increase in request duration for my web service, for my web store. Wonder if I can troubleshoot that a little bit deeper. Okay, so let's have a look at some details. Now in this dashboard, I can see a breakdown of the different microservices. We have a shopping service. This happens to be where the user comes in. And then we have a delivery service, a styling service, a pricing service, and a bunch of other things going on here. First thing I want to see is, do I have similar behavior in all my nodes? So I'm zooming in on the last hour, and as you can see, the graph is kind of moving, which means this is a live view. This is real-time data coming in. If I look over my last hour, I can see that my performance or my latency on this service is hovering at around 1 second. If I look at the different nodes in the cluster, so each line here represents a node in a 3-node cluster, I can see that there's really not much difference between them. I'm kind of bouncing around the same way here. So there's not one node that has an issue. This is a systemic issue across this microservice. Now, if I look at the other microservices here, I'm already seeing a pretty interesting hint here, right? It looks like the pricing microservice is also taking a lot longer than I want it to take. So that might be the issue we're looking for. But let's do a little bit deeper troubleshooting, shall we? So let's drill down into the tracing. So tracing allows me to drill even deeper into the application itself. So here I'm seeing the most requested services, the services with the most errors, and in this case, the services that are the slowest, which is of course what we're interested in here. And as you can see, the one that is the slowest is indeed, there it is, pricing. Okay, that's kind of what we thought, but let's drill a little bit deeper. Now we're looking at individual traces from this application. What it's about to load here are the 100 slowest traces or the 100 slowest requests for the last hour. Okay, so what we can see here is, first of all, we can see a map of our application. This is really helpful when you're troubleshooting something, because again, there might not be one person that knows the entire application if you have hundreds of microservices. Now in this case, we have about a handful of microservices, so it's really easy. But imagine a bigger application where this number might be 100. Not so easy anymore. Well, now we need to look at where the bottleneck seems to be. And it's pretty easy to see, right? Yeah, we have all this services calling each other. Shopping happens to be where the customer comes in. And then it calls styling and delivery and a bunch of others. But it also calls pricing. That is where the price for my order is calculated. And this seems to be doing spending a lot of time here. Okay. Now, let's drill down into that a little bit. And I can see what host this came from, or what node in the cluster it came from. I can even see really detailed things such as what the URL was. Okay, so let's take note of point 22. Okay, so that was one node. Let's have a look at a few others here. That was point 21 and point 3. So there's no one specific node that seems to be causing the trouble, which is kind of what we saw before. But yeah, that is consistent with what we saw on the other dashboard. Okay, what seems to be the problem here? Well, I know that the pricing application does a lot of database lookups. In fact, that's most of what it does. So it probably has something to do with that. Now, I could go and troubleshoot my database, but in this case, we're having such a serious problem. Remember, we're actually losing money because of this. So what we need to do is we need to fix this quickly. And what do you do when you want to fix something quickly? Well, you kind of go for something easy and you're going to test it out real quick. So my developer here, he says, I think I know what the problem is. I think it's a specific database query that has a problem. So to kind of fix it in a quick way, I'm just going to increase the cache so that more queries will be satisfied by the cache and it doesn't need to execute that database query so frequently. Okay. We're really in a hurry here, so we need to test things in production. How do you test something in production? Well, what you normally do is you do what's called a canary deployment. In a cluster of many nodes, in this case we have a 3-node cluster, what you do is that you change one of the nodes for some of the users and you measure. So let's see what we can do here. Let's run the canary deployment here. All right, so that should kick in, and it should kick in here in a few minutes. We should start seeing the results from this. Before we continue, let's talk about how we got all these traces. So there are several ways you can get traces into Wavefront. We can use a tracing framework like OpenTracing, like Zipkin, like Jaeger, and we can actually compile that into our application. It's actually really simple to do. But what we did in this particular case is that this actually runs in Kubernetes, and we can apply what's called a service mesh to it. So by applying a service mesh, in this case, it's Istio. By applying Istio and Istio Envoy to this, we get the traceability for free. We don't need to change anything in our application. This is just a sidecar that we apply to our pods, and it will sit there and it will monitor all these calls without us having to change anything in the application. So everything you see here today is coming from an Istio Envoy sidecar, and I made no changes to this application whatsoever. All this tracing just comes from that. So now that we have a potential quick fix for this, and while we're waiting for this data to show up, it might take a minute or two before we see the effects of that thing that we pushed out, the canary that we pushed out. Let's have a look at what's going on with the database. So let's see if we can see anything interesting in the database. So I got some good and some bad news. The good news is that we are in fact logging all the slow statements in the database. The bad news is that the application isn't really instrumented to tell us what statements it's executing. So here we have the pricing latency, which is what we were investigating, right? And as you can see, yep, it spiked up here. Now here are all the slow SQL statements that take more than 800 milliseconds. And I picked 800 milliseconds because that happens to be the threshold for our SLO, right? So anything that would contribute to breaching our SLO should show up here. And unfortunately, it is not really telling us much because there are a lot of SQL statements in this application. And a lot of them take a little bit of time. And most of the time that's totally legit because there might be just complex statements and we allow them to take a little while. So this didn't really tell us much. But here's where the magic of Wavefront comes into the picture. What we can do is we can run a correlation between these two things. So basically, what I'm asking Wavefront is now, hey, is there anything in this mess here that kind of sort of looks like this? And this is what I get out. Wavefront says that yes, there is. There is in fact this select price from quantity price table something something, right? That looks like it's a database join. So out of all that mess, out of all that noise, I got my interesting signal. I got the SQL statement that seems to be correlating with this. And it makes sense, right? Because we were looking for something that had to do with pricing, and it seems to be selecting something from a pricing table, and yeah, that makes sense. So now we know exactly what statement it is. We don't really know why it is a problem though. Well, here's another thing about Wavefront. So far, you've seen us go wide. We've been through many components of the application. Now let's go deep. So each technology, be it a database, middleware, queuing, whatever, anything that you're using has a plugin in Wavefront. In this case, we're looking at a database plugin. So here we can see a lot of different metrics. We can see all the connection metrics. We can see how many users are using us. We can see slow statements. We kind of did that already. Let's see if we can see something else that correlates with this, with the behavior we saw. Here's one thing I'm seeing that correlates with the behavior we saw. IO wait. So whenever we see that slowdown, we also see an increase in IO wait. And we see an increase in IO wait time. And if you look at the second column from the right, you're starting to see here that the slowest or the most IO wait seems to be in the price table. We kind of thought that might be the case, right? Okay. But why are we seeing all this IO wait? Remember, IO wait is when it needs to read a lot of things from the disk or write a lot of things to the disk. Why are we seeing that? Well, let's have a look at something else that correlates with that behavior. Index wait. Now, index wait means how long we're waiting to look something up in an index. And if you look at the worst offender here, it is again that price table. And look at what that index is called. It's called none, which means that there is no index in the database that could satisfy this query. So it's actually scanning the entire database, or the entire table, I should say, for this pretty complex join. That is our problem. Our problem is that somehow somebody dropped an index in the database. Maybe they did some maintenance on it. Maybe they regenerated a table. Something like that happened, right? And we can clearly see that at this particular point, things started to go bad. And we had this horrendous index wait. Cool. Now, let's go back and see what happened to that Canary deployment of ours. So now we're back to our service breakdown dashboard. Let's see if we can see any changes here. Well, one of the things I'm seeing here is that it didn't really affect the overall performance that much here. But if we look at the pricing service in detail, you're going to see that there are 3 or actually 4 nodes in this cluster. And then at this point here, there is another one coming on board. And this one seems to be performing a lot better. This one takes about 3 milliseconds instead of about 1 second. And that is our canary that we just deployed. So the fact that this one is so much faster than the others is very promising. We can also check if it has more errors. Let's go and look at the troubleshooting of the service. Let's look at the traces. And in fact, this number of errors did not go up, so we didn't break anything. We can still drill into our slowest requests here. Not surprisingly, pricing is still the slowest, because remember, we only changed 1 out of 4 nodes in this cluster. So if we were correct here, we should see, if we, instead of looking at the longest, we look at the most recent ones. Here we go. If we look at the most recent ones, we should see that about 1 in 4 requests should be really fast. Because remember, you have this cluster where we replaced one of the nodes with a faster version, where the version had more cache. And indeed, right? Check it out. We have some of these requests are a lot faster. Should it be about, if we scroll down here, yeah, it should be about 1 in 4. That's a lot faster. So if we look at the slow one here, it still spends a lot of time in pricing. And if we look at the fast one, all of a sudden pricing takes 3 milliseconds. Looks like we fixed the problem, because the query is now satisfied by the cache instead of having to go out to the database. Excellent. So we can see here that the node that processed this, it only took 6 milliseconds. And this was .2, right? So let's see, let's do a spot check here and see if the other one is .2. Yeah, it seems to be consistent across the board here, right? So yeah, all the fast ones seem to be happening on that node, which was the node that where we replaced the code and we added some more cache to it. So it appears like we fixed the problem. Now what I can do before I start bugging my DBAs to fix that problem in the database is I can actually roll out this cache change to all of my nodes. And here we go. Let's roll out that cache change to all the nodes. While we're waiting for these changes to take effect, let's recap what we did. First, we got an alert in Slack saying that we were breaching an SLO. That SLO basically told us that we were supposed to finish the transaction within 800 milliseconds, and we did much worse than that. From there, we were popped into a business dashboard where we could see the revenue. We could correlate the revenue that was passing through the application with the performance of the application. And we saw a sharp drop in revenue. So this was definitely something we needed to look into. This helped us triage the problem, obviously, and we realized that this is something we need to give high priority because we were losing money because of it. I could use the sharing functionality in Wavefront to send a link to my developer so that they could see exactly what we could see. From there, they were able to troubleshoot the various nodes and the various microservices in their application. And they were able to isolate the problem to a specific pricing service. And in order to fix this quickly, they tried to do canary deployment. So they tried to do a change on one single node in a cluster and see if that had a positive impact. So what they did was they increased the cache, and indeed that helped. Now, from there, we went into the database and we were able to correlate automatically which database statement was the most likely to cause this slowdown. And we were able to go even deeper into the database, and we were able to correlate that with an increase in IO weight, and we were able to determine that the increase in the IO weight was due to a missing index. We could even see exactly when that index disappeared. So, Now towards the end of the demo here, did our change work? And if we look at our graphs here, we can see that all these nodes went away in our cluster and new ones came back and they are much faster. Same thing here with the pricing service, right? The pricing service was the one taking the most time. We can see that canary coming online here. We knew that, and we knew that that was good. So then we deployed to all the other nodes and it worked. That concludes our demo on Microservices Observability with Wavefront.